All right, looks like most of you are finishing up there, and that's fine. We're going to start on lesson 5, page 41. Okay, going to continue to look at graphs the next couple days. All ways to represent functions. We've made a couple graphs now. So which one doesn't belong there in your opinion? And please tell me why. Go ahead. The only one that has dots. Remember what that type of graph is called?
Dot plot.
No, not dot. No. I might not even have told you. It's called a discrete graph. Okay, the ones with dots are called discrete. Ones with solid lines are called continuous. Okay, so I heard B. Anybody else have one? Doesn't belong.
C.
Why?
Because it's the only other one that has sharp edges.
Sharp turns there, sharp edges, okay. Anybody choose an A? You choose an A as well? Alright, why?
Because it's the only one
The only one that goes up. It's also the only one that touches the x-axis. B is the only one that's on its side, maybe. Only one that is curved to the right. It's actually the only one that's not a function, is B. Just a reminder, to check if it's a function, you can check the vertical line test. And that means any vertical line you draw can only touch the graph in one spot. If it touches in more than one spot, it means it has more than one output. Not possible to be a function. So that's an easy way to tell if a graph is a function or not. If it touches it in more than one spot, it's out. It's the only one that's not a function. But again, whichever one you pick, define it, explain it, defend it, all those things. All right, temperature shows the temperature in Fahrenheit between noon and midnight on a certain day. So this is time after, hours after noon. So this means it's 1 p.m., 2 p.m. This would be midnight, of course. So it's hours after noon. So Adam, was it warmer at 3 or 9?
Oh, 9.
How can you tell that, Adam?
Because it shows that.
Yeah, I mean, that's not wrong. All right, which one's higher, 3 or 9? Pretty simple. Okay, approximately when was the temperature the highest? Zoe? Approximate time.
I'd say like 575.
Okay, that's not really a time.
575.
Oh yeah. No, let's go with 575.
Okay, that I think you mean 75% of an hour, or 3/4 of an hour, which is 45 minutes. So we're gonna say 5:45.
I'm making good time.
Okay, 575 to me then would be 6:15. 75 minutes would be an hour and 15 minutes. Okay, find another time. Nope, yep, find another time that the temp was the same as it was at 4. Go ahead, Sienna. 8 o'clock? Again, we should probably mention that it is PM.
No.
Did the temperature change more between 1 and 3? Or 3 to 5? Well, 1 to 3. Change that far. 3 to 5. 1 to 3 by a little bit, probably about a half a degree. I agree with that. 1 to 3. Does the graph show that temperature is a function of time, or is time a function of temperature? Okay, so my y-axis is temperature. Time is on the bottom. So it would be the first one. The output is listed here, the input is listed here, or the X and the Y. And again, it passes the vertical line test. Every time of the day only has one temperature it can be. Question number 6. When the input is 8, what is the output? Well, the input is your X, right? So when my X is 8, my output is 57. Now what does that mean in this problem? Well, that means at 8 p.m., the temp is 57 degrees Fahrenheit.
Can we talk about weather? Can that be our weather now?
Sometime in the near future. Maybe I'll just say future, not so near. We've been pretty spoiled with our temperature, actually. We're gonna get a reality check this weekend, after today.
I'm so excited.
5.3, speaking of cold temperature, we're gonna talk about garbage.
But
Graph shows the amount of garbage produced in the U.S. between each year, between 91 and 13. Wyatt, you're gonna have the honors of letter A. Would you read it, please?
Does the amount of garbage increase or decrease between 1999 and 2000?
No.
yes.
Increase or decrease? Taylor?
Yes.
Increase.
Why? How do you know?
Because of weight.
Yeah, some of these are pretty simple, right? The graph went up, right? Increase. How about 05 to 09?
Increase it.
Yeah, so it kind of increased and then came back down. So overall, I would say it decreased. All right, kind of did both. And C. Ian, would you read C, please?
Between 1991 and 1995, the garbage increased for 3 years. Then it decreased for the 4th year. Describe how the amount of garbage changed in the years between 1995 and 2000.
All right, so if you look from 91 to 95, they said it increased 3 years and it decreased the 4th year. So how about from 95 to 2000? Did it increase every year? Did it go down? If so, how many years? 95 to 2000. What happened?
It went up. It decreased 1 year.
Decreased 1 year and then went up every year after that. Okay. So decreased 1 year, increased the next 4, or for 4 of the 5. Okay, same type of question. I would like you to see if you can answer question number 2, please. All right, Lily, when was it increasing? When was the graph going up?
1990,
Till when?
1995.
Yeah, you probably can go 96. Then it went down. This one's kind of hard to see. You think that one went down too?
Yes.
So 96, 97, so 98. Increased all the way to 05, 06, 07. Then it went down again. And then from 8 to 11. So 3 different increases there, 3 times the graph went up. Decreased, when did it go down? Well, it went down from 96 to 98. And 07, 08. And then 11 to 13. Okay, hopefully those are going well for you. It's literally when are the dots going up, when are they going down? Just gotta make sure you're careful with what years you mark down. Lucas, can you tell us the story of the change in percentages over this time period? Can you kind of summarize what's happening in that graph?
Well, basically, it kept rising, then it hit a point to downfall, and then it kept rising to downfall again.
Yeah, so basically putting what we just wrote down into words, right? The amount of garbage that was recycled increased until, or from 1990 to 1996, decreased a little for a couple years, then increased again for the next 9 years, decreased for a year, and then increased again. So you're just describing what you wrote down into words is all you're doing there. All right, the final question then is the Are You Ready? Let's do that one today. Taylor, would you read number 1, please?
Find a year where the amount of garbage produced increased from the previous year, but not as much as it increased the following.
All right, so we're looking for a year. We're going to go back a page and look at that one where it increased, but not as much as it jumped the next year. So can you find a way or a spot where it increased, but it didn't go up as much as it did the following year? So a small increase followed by a big increase. Say that again. 2001. I don't think the second one is as big of a jump. Oh, right here you're talking. Yeah, that would work. This jump is small, this one is larger, so that would be 2000, 2001, that would be 2002. So the year that it increased, let's read that again. Yeah, so 2003 is when it increased, and then the next year it jumped even further. Okay, question number 2. Claire, would you read that one, please?
Find a year where the amount of garbage produced increased from the previous year and then increased by a smaller amount the following year.
All right, so big jump followed by a little jump is what you're looking for there. I mean, you could do this first one. This is a big jump followed by the small jump. This is a big jump followed by a small one. So either one would be fine. Let's choose this one. That would be 96 to 97. Othniel, would you read number 3, please?
Find a year where the amount of garbage produced decreased from the previous year, but not by as much as decreased the following year.
All right, so the big jump, and then it's going down this time. So big jump down, and then not so big jump down. Couple options there, right? Where it went down. So big jump followed by, it still went down, but not as much. So you could talk this one maybe, went down, and then it really went down. You could even do these two, I guess. 05, 06. You could say 07 or 08, either one would be fine. And then 4 is going to be decreasing from the previous year, decreased by a smaller amount the following years. So decreased and then decreased a smaller amount. So pretty much the same question. What do you think on that one? Got another one? '94. Yep. Big jump, small jump. It's good. All right, again, just being able to study those graphs. A big thing people get confused with, like if on the summary, all right, does this mean 1 o'clock, 2 o'clock, 3 o'clock? Notice it's hours after 8, right? So this is actually 9 p.m., 10 p.m., 11 p.m., midnight, 1 a.m., and so on. Okay, so really watch what you're graphing. Watch those labels. All right, so there are 4 questions here. The first one is matching. Notice the directions there. We don't just have to match. What else do we have to do? Label. Okay, so underline that. So you're going to label these axes as well, right? Are you doing time and temperature? What are you graphing? So make sure you do that. Ian, make sure you make note of that. Question number 2, it says the solution to the following equation is 6, -3. Choose 2 equations that might make up the solution. That means if I plug in this for x, 6 for x, and this number for y, it'll be true. Happens twice there. 2 of those 5 work. Question number 3. Car is traveling on a small highway, and it's either going 55 miles an hour or 35 miles per hour, depending on the speed limits, until it reaches its destination 200 miles away. X is how long I go 55, and Y is how long I go 35 in the following equation. So if the car spends 2.5 hours going 35 miles per hour, how long do I have to drive 55 miles an hour? So if I go 35 miles for 2.5 hours, how far can I make it? Driving 35 miles an hour for 2.5 hours.
87.5 miles.
Well, you take 35 times 2.5. 87.5 miles. So if I take 200 and I subtract 87.5, I get 112.5. So that's how many miles I got left to go. If I drive 55 miles an hour, how long will it take me to get there? $165 hours?
No, I'll wait. 3 hours, 55 miles. That's 165 miles traveled.
How long do I have to drive 55 miles an hour for to make it 112 miles? Okay, you're going to whatever, your lake cabin, 112 miles away, you drive 55. How long is it going to take me to get there? 112.5 divided by 55 miles an hour. 2.05 roughly hours, so a little over 2 hours. And then you're gonna have to answer a couple more questions from that, just like we did. Final questions, again, just analyzing the graph, make sure you label. And 4C, it does say indicate the situation, where does it happen at? Make sure you point to that on the graph. So only 4 questions once again today, 46 through 48, please.